Hello, welcome back to Every Problem. This is the Stewart Calculus 8th edition, section 1.4, problem number 17. It says, starting with the graph of y equals e to the x, write the equation of the graph that results from, and then we have a list. They give us a shopping list, I guess. So 2 units down, 2 units to the right, reflecting about the x-axis, y-axis, and then both the x and y-axis. So luckily, I'm not sure what problems you were assigned or anything. Luckily, we did already work with all of these circumstances in 11 through 16. So yeah, let's go ahead and get started. So for A, 2 units downward, that's going to be a y translation. So we'll have y equals e to the x minus 2. That will shift our graph down 2 spots, okay? B, well, 2 units to the right, we'll have to do something like this. Y equals e to the x minus 2. And I'll show you why really quickly. I won't get into too many details here, but just a quick explanation in case you're wondering. So naturally, e to the x has the point 0, 1, and it has an asymptote at the line y equals 0. The graph takes some sort of shape like this. Okay, so how is it that we shift the graph over by 2 to the right when we have x minus 2 in parentheses? Well, if I have y equals e to the x and you plug in 0, as we have here, you just get e to the 0 and that equals 1, okay? Well, how do you make e, if we have e to some quantity and it's x minus 2, if we need e to the 0, how do we make that? Well, we would have to plug in 2. And that way we would get e to the 2 minus 2, which would be e to the 0. So what would happen is we would plug in 1 and 2. There we go. We'd plug in 2 for x. That would give us e to the 0, and e to the 0 is 1. So then we would have that point right there. So that essentially takes the graph and it shifts every point over by 1. Well, by 2. Sorry. I hope that wasn't confusing. It shifts everything by 2 because in order to get the same y value, we have to plug in an x value that's 2 more than the previous. Okay? For part C, let's see, what does part C say? Reflects about the x-axis. So the x-axis, I'll draw this over here. We need to reflect here about this axis. So for a translation like that, we're going to have to put a negative coefficient in front of our e. So we would have y equals -1 times e to the x. Okay? For part D, if it's about the y-axis instead, then it'll have to be -x instead. So we'll have y equals e to the -x. And the reason for that is because, well, let's start with e to the x. If it's like this, if x equals 1, 2, 3, and 4, you get positive values because you have e to the 1, e to the 2, 3, and 4. If it's negative and you have e to the -1, -2, -3, that's equal to 1 over e, 1 over e squared, 1 over e to the 3rd, and so on. So if we apply the negative value to every x, then negative inputs will become positive, positive inputs will become negative, and the whole graph will shift over like this, and you'll have this line of symmetry along x equals 0. Okay, so then we can combine those two. It says reflect about the x-axis and then the y-axis. Luckily, order doesn't matter, so there's not some weird special trick we have to do. So we would just have y equals -1 times e to the negative x. And that's everything. Yeah, that's going to be it for problem number 17.